So today's topic is engineering tools and really looking at how the engineering tool set is moving beyond CAD and PLM to take advantage of a digital ecosystem. And I know that this is a transition that many of our customers are in the midst of, perhaps just looking over the cliff of pursuing. But I'm joined today by two industry leaders of organizations that have worked their way through a digital transformation, or should say working their way through a digital transformation. So I'm joined today by Kevin Duane of Halliburton and Rudi Wilhelm of ASM. So we'll get started with just some introductions. I'm going to be the master of ceremonies today. My name's Rick Hyde. I'm a director of customer success here at aPriori. I've been at aPriori for about 6 years now, and gotten the pleasure of meeting many of you and engaging with many of our customers through this digital transformation, aPriori transformation. Well, I'll take a few minutes and let my co-presenters introduce themselves. Kevin, why don't we start with you?
Yeah, hello everybody. My name is Kevin Duane. I am an engineering manager with Halliburton Completion Tools. I've been with Halliburton 30 years, and over that time, I've had the opportunity to lead a lot of changes within the organization. I think more than anything, that's what I do. I've kind of become an individual that identifies opportunities and helps lead the organization through those types of changes. So when digital came up, I think I maybe was an obvious or a logical choice anyway, to be involved with that from our engineering department. And so we've been looking, well, we probably earnestly started this maybe 5 years ago. But looking more at how cost impacts our business and how we can improve our business to be more efficient using digital tools and digital transformation. And I think the pandemic obviously put a razor's edge on that need. So it's become kind of a corporate-wide drive now to digitalization and digitalize so that we can communicate better, more efficiently, with fewer errors and improved quality all at the same time. So,
excellent. Thank you so much, Kevin. And I'm also joined by Rudi Wilhelm, Director of Engineering for ASM. So Rudi, I'll turn it over to you to introduce yourself.
Okay, thank you, Rick. I'm Rudi Wilhelm. I'm working for ASM. ASM is a company that makes equipment for the manufacturing of computer chips, so semiconductor manufacturing equipment. I've been with the company a little bit over 30 years, like Kevin, with his company. And in the 30 years, I've had various positions in research and development. So developing the products that our company sells. And in the last couple of years, I've been responsible for a global engineering team. We support our design engineering teams, which are spread over the world, in becoming more efficient in what they are doing. And so you have to think about the product lifecycle process, and then specifically the design portion of it. How can we do that more efficient? And that's both in terms of time to market, but also in the quality of what we develop over time. Now, if you look at time to market, then of course product lifecycle management systems are very important. But it's also important that we reduce the time we need for testing, validation, optimizing. So virtual prototyping becomes more and more important, because every iteration that we can cut out where we have to order parts, test parts, and improve them is a lot of time that we can gain in the overall product lifecycle time. So when you look at cost, for instance, traditionally, we only learn anything about the cost of a product, the cost of parts, when we start ordering them for prototyping. But with a tool like aPriori, we are now in the lucky circumstances that we can analyze the cost before we even order parts. So we can have our first design iteration for cost already before ordering the parts. And this is just one example of where I think digitalization is going to help many companies. So we are really in the process of making the 3D models the single source of truth, create as little drawings as possible. So really do as much as possible with the 3D models. So besides the cost analysis with aPriori, we also do more and more CFD and FEA analysis. And And we try to use the models more and more also to provide the suppliers with the right information without the need of detailed drawings.
Excellent. Thank you so much, Rudi. So what I'd like to do next is just provide maybe a little bit of context or background for why I think this conversation is important. And one of the benefits I have in the role that I have at aPriori is I get to speak with a lot of our customers. And one of the major themes I'm hearing recently in the last 12 to 24 months is that product life cycles are reducing. And I think some of that's led by consumer demand. I think that some of it's led by the pace of technology advancements. But what it's definitely leading to is shortened development times. And Kevin and Rudi, I think both of you alluded to that during your introductions, that over your 30-year careers, you're seeing these lead times being compressed within engineering. And I'm reminded of a conversation I had with a VP of engineering in the automotive space a few weeks back. And one of the things he said to me was when he started his career about 20 years ago, the time to develop an automobile was somewhere in the 6-7 year range. And if he fast forwarded to 5 years ago, that was cut down to a 4-year development process. And what he's seeing today in the marketplace, with the disruption of EVs and different sorts of companies that have entered the space, is he's pushing his team to develop automobiles within 24 months. So a really dramatic shift from 6 years to 4 years to 24 months. And what that's forcing organizations to do is think and work differently. I'm seeing a lot of engineering organizations and enterprises as a whole really think about how they're being proactive in their behavior, right? What sort of early insights can they get before they move to even the prototype phase about weight or manufacturability or cost even on, is this product worth pursuing? Is it not worth pursuing? And knowing very early on. The other thing that I'm seeing is this is forcing organizations to think about how they're collaborating and the tools that they're using to collaborate, both internally and externally. When I think about internally, I'm reminded of when I started my career in the aerospace engineering segment of the term just throwing it over the wall, right? We would take our design, we'd throw it over the wall to sourcing, and they would do what they need to. And when we think about cutting product development processes in half or by two-thirds, excuse me, the idea of throwing it over the wall can't exist anymore. And we've got to have a really tightly integrated engineering, sourcing, quality organization. And when I think externally, we've also got to focus on how we're interacting with our customers and our suppliers, right? It is truly one integrated supply chain that your organizations play a role in. And how we're interfacing with those customers and suppliers. The chart I have on the screen here is based on some work done by the consulting firm Kearney on some of the shifts that they've seen through the engineering process over time, right? Starting with the traditional approach, the waterfall resource focused engineers. And then I'm sure you guys through your careers, you've seen some of these buzzwords as well, right? Lean engineering, agile engineering. The idea of modular architecture driving cycle time reductions. When we look at agile, looking at the customer value focus and open ecosystems. Where I really want to focus today's conversation is around the digital thread, right? And the move to digital research and development, where the customer and suppliers are part of that development process. There's no idea of gathering requirements, taking them from your customer, doing your design work, and then flowing them over to your suppliers. It really is a single integrated digital team with that system level integration, right? You're able to take advantage of that CAD model to do things that 20 years ago, perhaps you'd never thought of. And then layer on top of that, the AI and automation piece, and the design ecosystem looks a lot different than it did even a decade ago. So I wanted to use this as setting the baseline, right? We know that product life cycles are getting shorter. We know that engineering is becoming more digital. And that's going to lead me to my first question for the two of you is, I'm interested in both Halliburton and ASM as you guys approach this digital shift. What was the catalyst for you guys? Was it a customer push? Was it efficiency or market demands that I just talked about? I'm interested in what it was for you guys. And Rudi, maybe we'll start with you.
I think for ASM, it's really time to market. So the development cycle time is driving most of the improvements that we are working on, and that can be summarized indeed as digitalization. In the last couple of years, we implemented a PLM system. Before that, we only had drawings. Yeah, we had the 3D models, but they were hidden somewhere in a closet, and only engineers had access to it. So the drawings, that is what we were communicating with. Now, if you look at a 2D drawing, determining manufacturability is quite hard, or serviceability. It also means that we only got feedback from service engineers, from manufacturing engineers on the manufacturability and serviceability once we started ordering the parts. But like I said in my introduction, if you then have to make changes, you have to make the design change, you have to order parts, the lead time of the parts, you get them in your hands, and only then you can give feedback again. So we realized that besides having a much better integrated product lifecycle process, that having access to the 3D models for all the stakeholders is extremely important. So that was one of the driving factors for implementing PLM. So now everybody in the company, if they have the right access, can see the 3D models. And that allows people to give feedback real time while the engineers are still working on it, on their designs. And so, like I said, that started with manufacturability, and serviceability. But now with aPriori, we're also using that for cost analysis. And again, the same story is true. Although cost is a slightly different aspect, because we will not stop with releasing a product if not all the cost targets are met. But the time to profitability is significantly shorter if you take cost really into the design phase. So that's where another advantage of having all those tools available early in the design phase it really starts playing an important role. And we see more and more possibilities of working with the 3D models. If you look at traditional field instructions, maintenance instructions, you see it's a lot of text with a few pictures. Pictures are outdated by the time that you take them. But with the 3D models, and using the 3D models to break it down in, or use them really to very visualized 3D based instructions, also shortens the time to market. It shortens the time it takes to create those instructions, but it also is much easier to consume, to use for manufacturing technicians and field service engineers alike. So we see a lot of opportunities of working with 3D models and making that available for all the stakeholders.
Excellent, excellent. Kevin, I'm interested in Halliburton's journey. Was it guided by something similar?
Yeah, I think probably all of the above. I mean, time to market, customer demands becoming more urgent. We'll use that word. We focus a lot on engineer to order. And so our projects come in all different sizes, from very quick changes to align our product with the customer's particular thread solutions on their wells, that type of thing. So our projects tend to vary pretty considerably. I think for us, what we recognized was that there was a lot of disjointed activity in our design process and a lot of redundancy. And so you have all these tools that we're using, whether we've had CAD and PLM for close to 25 years now, but the way we implemented those tools, I think over time has started to kind of the methodologies that you put in place to use them have potentially started to make us less efficient today, because we have to enter information in one system, put it in another system, and put it in another system. And then how that information gets utilized when it goes to other functional areas in the organization, whether it's manufacturing, whether it's business development, whether it's operations. So I think the driver for us really in our most recent push is all about, it's not just the applications that we're selecting to use, it's how those applications integrate with one another and how they can communicate with one another with less or no human interaction. a big limitation of drawings is the fact that I have an engineer who spends a lot of time to create a drawing, put GD&T on a drawing to, based on their interpretation, the best way to communicate the design standard to a manufacturing engineer, to an operations engineer, or to a customer, right? But then because that's a document, that customer, that manufacturing engineer, that operations engineer has to interpret through the language of GD&T what all that means. And you can have disconnects in those various interpretations. Some of the new tools, model-based definition, like that Rudi mentioned, what they offer is the ability to standardize across those functional areas in what the interpretations of a particular geometric callout is, or a particular piece of geometry. And so then when you start to talk about integrating other applications like aPriori, it becomes very important that that tool integrates with that workflow, right? So that it's not just I have to do work here in my CAD system, and I jump over here to aPriori, and I might have to do some redundant work to make sure that the models talk to each other. So that integration is really important, and the ability for those tools to talk to each other seamlessly.
Excellent. Yeah, Kevin, I'm glad you mentioned integration. Hold on to that thought. We'll come back to it in just a moment. But I'm curious how, going digital, using models has changed the way you interact with customers and suppliers. You guys have mentioned internally focused, having stakeholders that are access to 3D. Kevin, you alluded a little bit to less interpretation around GD&T. I'm interested in how you guys have seen the shift to using models, and perhaps using models with your suppliers and customers, the benefit that's led to for both of your organizations.
Yeah, I can answer that for the semiconductor industry. I think depending on where you have your manufacturing, not all our supply chain is really capable yet of using model-based definition. So we are, I would say, in the middle of a transition, or even at the beginning of a transition, of using the 2D drawings and switching that really to using the 3D models without the need of any 2D drawing. We see some initiatives with some of our colleagues in this industry that are taking bigger steps towards using the 3D models. But we see in our supply chain that still the majority relies on the 2D drawings, especially when it comes to programming their inspection equipment. We do already for quite some time provide the step files as a neutral file to program the tools, but also always for inspections, people still ask for 2D drawings. So we are thinking how we can jumpstart this whole model-based definition, and so that we don't rely on our suppliers, because then we rely on the slowest one, and we rather serve the fastest one who can adopt this new technology. So there we definitely see challenges on the receiving side.
Yeah, I would agree. I think I guess the big change for us, we do a lot of our manufacturing internally. So we have been leveraging models in some form for a long time. What we find the limitation is carrying over the PMI, or the product manufacturability information. Even today, our models, the use primarily relies on, we rely on the geometry only, and we still rely on 2D drawings for the PMI. So I think the changes that we're seeing is you're going to see a drive towards incorporation of the PMI into the model, so that it can all be utilized there, both by CNC programming and by CMM inspection equipment. When it comes to third parties, and this is where interoperability is going to come back into the equation, I don't want to have to limit my potential use of suppliers based on their ability to read my content. So for us, it becomes about providing content that a supplier that might have a capability that I really want to leverage, even if it isn't to the level that I'd like it to be. So for us, it becomes about the tools being able to provide content to take advantage of the skills and or the capabilities that we need to in our supply chain.
Excellent. Excellent. Thank you so much. Kevin, in the previous question, you mentioned the idea of taking information and entering it or pulling it out of one system and putting it into another manually, and spoke to the value of integrated systems. I 100% agree with that, right? The more we can pull the human out of the ecosystem, the better spot you'll be, and they can focus on, what really matters, the real design problems that they're facing rather than the data entry. When you guys were thinking about or planning, your engineering workflow, both from the user and product perspective, what were some of the things that you were considering in doing that and putting that ecosystem together? Kevin, why don't we start with you since you brought the topic up?
Well, I think in the early days, there was a struggle when you started talking about PDM or PLM and MRP systems. You have the whole, there's a need to align the software workflow with the actual workflow. And there was 20 years ago, there was a kind of a mantra in the industry about, not letting software drive your workflow. But I think today you have to take it's a little bit differently. I think today you want to look at how software can improve your workflow, and how it can align with it. There are obvious things in your workflow that you can't change, whether it's regulatory or whether it's quality. And I think that becomes important because there's really two schools of thought on software, right? I can purchase an all-in-one solution from a big box provider like, Dassault or ProE or something like that. And you can incorporate all of their tools, or you can incorporate tools that are more appropriate for the various aspects of your workflow. So, we use SolidWorks predominantly as our modeling tool, but CAMWorks may not necessarily be the best CAM solution for our manufacturing environment. So you start to look at how does that, I need interoperability. And I think vendors need to understand that becomes important, because I'm not necessarily going to always be able to utilize one provider's solution. And then you have to look at how those tools and the integrations that you can create between those tools, how they can improve your workflow. And so I think the old mantra that, don't let software drive your workflow, I think really needs to be set on the sideline. And you kind of start to think about, go talk to users, talk to them about what they need, what they do, how you can help them with software and workflow improvements, but at the same time, recognize that their perspective is somewhat focused, maybe to a very large degree, focused and influenced by their environment. And as a manager that's trying to, incorporate a better, more improved digital workflow, you can't focus at the individual contributor level. You have to be able to help that individual contributor understand how the bigger picture plays in, and how what you're asking them to do, whether it's in software, whether it's in workflow, creates advantages for the organization, right? So I think today it's a much more, we'll call it intangible problem. There's a lot more moving parts. It's more system oriented for sure. You have to think in terms of systems, right? How does what they're doing in the CAD application affect my simulation tools, whether it's cost simulation or finite element analysis or computational fluid dynamics? But also, how does that affect what manufacturing needs to do? How can you change what manufacturing does to better leverage what engineering does, and vice versa? Those are all questions that I think are real need to answers in today's digital movement.
Excellent. No, I appreciate that. And one of the things that you mentioned, Kevin, that resonated with me was software driving the process versus vice versa. And I think that there's some give and take there. But anytime, I'm looking at a change in process, one of the things that comes to mind is there's going to be a cultural change element of this, right? An adoption element of this. And as you're considering implementing new softwares, new workflows, new practices, how do you approach that cultural change with the individual contributors?
So I guess for me, it comes down to, you hear the common language about you got to have leadership buy-in, you got to have, good direction, good messaging, and that's all true. But to me, what it really comes down to are, I read a book one time, there's 6 sources of influence, right? And when we talk about sources of influence, it's I think sometimes there's a tendency to confuse influence with manipulation. And but what you're really talking about when you're talking about influence is addressing all aspects. So you've got what's important to the individual and what you can do to provide them with guidance and opportunity to influence their behavior. But you also have to recognize that the system is acting on them, whether it's their direct department, their direct. So you have to address social sources of influence as well as personal sources of influence. And you have to create a situation that enables them to want to change. Because I had a friend of mine who works in the aerospace and defense industry tell me, with regard to changing to model-based definition, he goes, why do I want to do it? He goes, I'm an expert at creating drawings. I can whip a drawing out in no time. Why would I want to stop, slow down, and have to learn how to use new tools in order to create and document my design? And what his answer demonstrates very clearly to me is that that answer evolves from his personal efficiency and how he views his impact and his input to the overall design process. He doesn't really consider what that drawing might create downstream for manufacturing or operations. And it's not a criticism. It's just the way we're wired. And so if you want to really influence the culture, you have to help individuals understand that, yeah, I'm going to ask you to slow down and learn a new skill, but what that new skill will ultimately provide for the organization at large and for you as an individual once you've mastered it. Because he wasn't always a master of the 2D drawing either, right? It's a skill he's honed and developed over the years. So you have to help them see all of the sources of influence and all of the sources of benefit, because we're just not wired that way as individuals. We tend, and our organizations aren't really wired that way either, right? They reward his ability to whip out that drawing in no time flat, right? So, and when you force them into a situation where you're asking them to change, they slow down a little bit, and the organization tends to want to punish that. So you have to manage all of that. It's a monster. It's difficult.
It can be, for sure. Rudi, I'm interested on ASM, if you guys faced similar challenges and how you approached them.
I think the challenges are very similar. I sometimes say that engineers like to change everything except their own working methods. And I think that's true because they have become very efficient in their way of working. And so we always try to look for what's in it for the users that have to change. So not only focus on the end result, why it is good for the company, but also see if there are at least elements that are of benefit for the specific user group that is going to experience a change. But that's not always possible. So then it becomes extremely important to explain indeed in large detail what are the benefits for the company. It's also interesting to see that even when you think that there is benefits, for example, for an engineering organization to change the way of working, they might not even be interested really in the change. So I was referring before that we want to move away from creating complex drawings. We still make very complex installation drawings that shows how an assembly fits into a larger assembly. From my perspective, if I have a 3D model that shows the full product, then I don't need that installation drawing. So I told them, don't create installation drawings anymore. But they are so wired indeed that they have to create installation drawings that it is very difficult to convince them, even although they know that it takes a lot of time. So like with many things, it's communication, looking for what's in it for the user, but and very clearly explain what is the benefit overall for the company and what are the steps to get there. That's coming back every time with every change we make.
Excellent. No, I appreciate both perspectives and also appreciate the common challenges. I will say, you guys aren't alone in those challenges. They come up. Every customer I speak with has something similar.
And there is one more thing that I would like to add there is that one thing that I didn't mention yet. Leadership buy-in is important, but you have different levels of leadership buy-in. So if you look at, for example, the cost of design, every company will say, yeah, that's important. But if you look at how many companies are really checking the cost of design at the during the design phase, then it's all based on people making estimates. Let's say a new product has 50% new parts, 50% existing parts. I know the cost of the existing parts, that's easy. But the 50% new parts, it's a guess. So you would expect that everybody embraces immediately the capability of doing cost analysis based on the 3D model. But if there is nobody who asks me as an engineer, hey, what is the cost of your of this design? And they wait until there is a quotation, then nobody will embrace aPriori. So we need that that buy-in from the people responsible for the product cost to really start asking the right question at the right time. And so sometimes for some things like aPriori, it is very important that checking the cost of design in the design phase, asking that question during design reviews, that becomes very common. And that's not necessarily an engineering only activity, that is more an product marketing activity.
Yeah, absolutely. I think that emphasizes the point that nobody can change without the help of others, right? As much as we believe we exist in our own ecosystem, there are other players and other influences. So I appreciate your guys' insights on that. I'm curious how, as you were looking at your engineering workflow and, where you needed software to support that or where you needed software to help change that. When you guys were looking at the thousands of available applications out there, what sort of criteria did you use to say, these are the applications that we want to bring in, this is how we want to change our workflow? How did you approach that problem of what's worth making digital versus what can I keep manual for now?
I'll jump in. I guess for us, it's really, there's been a couple of things that we've chosen. I mean, like I said, we've had CAD and PLM since the late 90s. And so those systems are very ingrained, very instantiated. So I think for us, the latest push really revolves around, like I said, efficiency, interoperability, and being able to reduce. I really want to reduce the amount of effort it takes for an engineer or somebody else in our organization to do the job that they do. But I also want to remove as much of the we'll call it busy work, asking people to take information from one system and information from another system and compare it and tell me if it's right or wrong, those types of things, because that's the type of activity that a software application lends itself very well to, comparing dimensional information in one system with another system, looking at a dimension on a design and telling me whether or not the finished part is within compliance. We rely heavily on humans to do that today. And what kind of the direction we're going in is where can we lift those? Because that's really busy work if you think about it, right? They've already invested the time and effort to put that information out there. And we've purchased systems that are capable of using that information, whether it's a CMM inspection machine or whether it's NC programming. But we haven't really connected the dots so that those two systems can talk to each other and free humans up to do, work that our brains do better, problem solving, solutioning and things like that. That busy work, when we're forced to do it, it's slower and it's prone to error, right? So coming back to the question, we try and look for software solutions that allow us to remove those bottlenecks, right? How can we make my CAD system talk to my CAM system more efficiently and without the need of a human to interpret the drawing into the NC program? How can I deliver technical content about the product to the field so that they can better execute and deliver to the customer? And so it all comes back to I'm going to select solutions and software applications that allow me to do that in the most efficient way. And then once you find tools that do that, you obviously have to evaluate them head to head with traditional ROI tools and things like that. But I think I would spend more money on a product that did more to remove those bottlenecks than I would for a product that maybe did a little bit less and cost less, right? So when you start to look at the whole cost of ownership kind of thing, I think we tend to lean toward where we can, because those quality those are hard to put a dollar value on, right? We do it, but how long it takes somebody to interpret a drawing and feed it into the CAM system, that's very difficult to measure, especially in a large organization where you have multiple resources doing it. So I think it all comes back to that, how can we remove those bottlenecks?
Absolutely. Thank you so much. Rudi, I'm curious if ASM has a similar approach in looking for bottlenecks and removing them through software, or if you guys use a different lens.
No, that's pretty much what it is. So we have an idea of how the ideal world looks like. But we are not always aware of what software is around. So we have embraced software that came out of the blue for us. We were not aware of anything that existed in that area, and then we heard about it, and it turned out to be very useful for ASM. But the criteria that we use to decide if we want to implement a certain piece of software, the first thing was really about eliminating manual work. So re-entering information, anything we can do to prevent that, we will go for it. And then anything that we can do to get closer and closer to 100% virtual prototyping, because those design iterations typically take long. So anything that is out there that could help us, we will seriously consider. Then any software that helps us to prevent mistakes, which is partially already covered by the software that prevents double entry of data, but there is more out there. So those are typically the software that we are constantly looking out for. What is available? So we get different inputs, of course, from different people, and we map that against the criteria that I just mentioned.
Excellent. Thank you so much. So I think you guys have both started to answer my next question a bit, talking about elimination of manual work, elimination of mistakes, time savings. But I'm curious, as you look back to half a decade ago, how has the shift to digital impacted your business in a positive way? Whether it's decreased design time, increased collaboration, what are some of the benefits that you're seeing of going digital? And Rudi, we'll start with you this time.
One of the, I think, clearest cases is that when I said we implemented PLM a couple of years ago, that doesn't mean that we didn't have PLM before, but it really meant that a fully integrated PLM solution, fully integrated the ERP. And one of the reasons that we did that is that we really wanted the people downstream, the sourcing team, manufacturing engineering team, to see the design work while it was still ongoing. And for often a design for a new product, it's not all finished on the same day. So certain sub-assemblies might be ready, and their sourcing already can start. And as long as you have a fully integrated solution, you can start that work already much earlier than when you have to hand it over to the team. And that is where we see I think the biggest change, that now when we really start ordering materials to build the first of a kind product, that all the master data preparation has been done. While in the past, preparing for the master data was triggered by the fact that we wanted to order. So that is probably the biggest change we have seen so far.
Absolutely. And I hear many customers speak to the capability of accomplishing parallel work through integration, right? Not waiting until the whole work package is done, but waiting until an element is done and then kicking off the next phase. Yeah. And how that's helping them reduce their design timelines. Kevin, I'm interested in Halliburton and the impacts that you guys have seen in shifting towards a digital engineering workspace.
I mean, I think for us, again, it goes back to the ability to collaborate better and do things in a more parallel. I think for the organization as a whole, efficiency, less error, better quality. But I think it's also forced us to realize that it's more complicated than just parallel streaming, right? There are certain things that have to happen in a certain order. But maybe the biggest thing is the ability to reuse information, right? To be able to pull information that we didn't previously have access to improve design, to improve manufacture. For us, digitalization involves the recognition that every part of the company has what we'll call a model, right? Whether it's, in engineering, we tend to think of our models as our CAD models and our designs, but our configuration management systems are models, right? Our manufacturing process systems are models. And I think what we realize and what we're trying to get to today is that a lot of the senior players in the departments that have been there for 20 years and all of the knowledge is right here, right? And how you get that information and how you bring it back, how you get it into the system in the first place, and how some of these models and some of these new software tools allow you to do that, and then be able to share it across the organization to make improvements. So whether it's me learning more about a particular product's life data in a well and bringing that back to the design team in a format that they can consume it, or it's manufacturability information and how I can bring that into the real-time design environment for a design engineer to look at how their geometry selections in their model affect the cost of the product. So I think for us, that's the biggest change. I think in the early days, digitalization, our first push to digitalization was maybe getting off the drafting board and having digital documents, but they're still documents, right? They still require a human interpretation to use. Now we're talking about, call it Internet 4.0, call it, Internet of Things, whatever you want to, whatever the latest buzzword is. What you're really talking about is another communication and language channel within your organization that allows the machines and the applications that you've set up to talk to one another and take advantage of, information passing from one system to the next. But then also, how that all fits together in one system so that you can start to leverage information up and down the organizational structure.
Excellent. Thank you so much. And my last question for today, and I'm sure there's some folks in the audience that, perhaps are early in this journey or just getting started. For the two of you that I won't say you're done. I don't believe continuous improvement is ever done, but perhaps further down the path. If you were to start all over again, what would you do differently? What would you like those folks to learn from what you've already done?
I would even more focus on adoption. So we come with all those nice new tools, processes, workflows, but how can we reduce the time it takes before users really adopt those new technologies so that you really start seeing the benefits as a company? So we mentioned, I think both of us mentioned all kinds of important critical success factors for that. But if I would have to do certain things over again, let's say for the last 5 years, then focusing more on how can we positively influence the users to adopt the new technologies, I would give it even more attention.
Excellent. Thank you.
Yeah, I think I would echo that. I mean, I don't know, some folks may remember I did a presentation at a Cost Insight where we talked about that, focusing on adoption and some of the tools that we use to get users to do that. So that's an absolute must, I think. And understanding how technologies diffuse into organizations or diffuse into social systems, whatever you want to call it, starting with the end in mind. I think the challenge within large organizations, especially, is, when we started our digitalization effort many years ago, the tendency was to kind of financial systems need and what do the manufacturing and supply chain systems need. And then we implemented our CAD systems and what they need. And then secondarily, we thought about make one talk to the other. And I think, so today, if I were going to give you any advice, I'd say the first thing you want to do is sit down and, maybe start with kind of an idea of what you want the whole thing to look like. What advantages do you want to gain across the organization, not just within the individual functional silos that exist in your organization? So maybe on some levels, it's maybe a little bit easier for a smaller company to do this. Larger organization to consider. So I think, but if that would be my advice, start with some kind of idea about where you want to be in 5 years. But understand that planning is priceless, but plans are useless, right? You got to change on the fly. Because new software tools become available, the market implements new challenges. Our society brings challenges. I mean, COVID is a perfect example of how something that happened in the greater society at large impacted the way almost everybody on the planet does business. So you have to have that flexibility as well. I think you have to be a great running back, right? You gotta be able to move, shift, change directions, accelerate, slow down, and adapt.
Excellent. I think that's the perfect way to sum up the conversation, Kevin. I think we've covered a lot of ground here, and some of the things that are really, really important and critical are the planning phase, understanding what you want your organization to look like 5 years from now, mapping that out, determining what are the tools that fit, and then to Rudi's point, how are we going to focus on the adoption of those tools and being flexible and adjusting. So I want to thank you guys again for the participation in this conversation. I learned a lot. I hope our audience did as well. I guess the point I'll leave you on is, if you are finding yourself at the beginning of this journey or even the middle of this journey, there are a number of experts here at aPriori that can help you plan this out, figure out where aPriori integrates into your digital ecosystem, and walk the journey with you. So I'll leave you there. If you are interested in more, please reach out to your account team at aPriori, your CSM, your sales director, your expert services consultant, and we're happy to help you through the process. Kevin and Rudi, thank you guys again. This was a really enjoyable conversation for me, and I hope it was for you as well.
Awesome.
Enjoyed
Thank
it.
you.
Thanks.
Thanks.